Good afternoon, everybody. Myself, Dr. Anil Hazarika. I'm the faculty member of Department of Physics, Cotton University. Due to present lockdown situation, we are unable to start the classes. Further, we have started online NetGate. Further, we have started a NetGate coaching center in our department. However, we are unable to run that also. So that is why I thought it is the best time to start online classes, so the student get benefited. So today is the first day. I will focus on the physics part. So basically, apart from typical study, we will focus on skillful approach, how to study, how to digest the physics in skillful manner. Because otherwise, it is very difficult to complete the whole syllabus. So we will give us tips how to extract the information from mathematical equation. So basic understanding of physics require the understanding of mathematics in efficient manner. So we will focus on that part. And apart from typical study, we are not going to give you the derivation and all mathematical derivation and equation as given in the normal classes. So if you follow my video, and accordingly if you study, and I do believe that you can easily qualify, because I have appeared many times this exam. I have qualified NetGate SLET also, so I have that strategy. Furthermore, you have to study that I will give you here. So this is very essential books, and I have a lot of experience on teaching on this subject, physics. I have already 6, 7, 8 years I have already teaching physics NetGate. So many of my students already qualified, and I do believe that you can easily digest the physics in the efficient way. That's what I am going to teach you here. First of all, I want to give you the list of books that is very essential and mandatory. If you want to qualify, you have to digest this book, and this book is not so hard, very easy book. And I will teach you how to study this book, how to understand the mathematical equation, how to solve numerical problem that often given in the NetGate exam. So NetGate question is not so hard question. If you see the solution of a NetGate question paper, you will find the solution within 2-3 lines. But question look very tough, and dimension of question is normally very big. So often what happens, students skip the question or do not want to understand. So basic requirement is the time management, skill approach, skill intelligent learning, so and management of time. So this is very essential and most important thing. If you want to understand the whole physics, anyhow you have to understand electrodynamics, statistics and quantum mechanics. If you understand these subjects very efficient manner, then you can understand very easily. So I'm going to do, so whenever I'm teaching in the electrodynamics, then I will merge the mathematical physics with electrodynamics. Similarly, whenever I will start statistical physics, I will merge with condensed matter physics, because most of the topic statistical physics like paramagnetism, diamagnetism, and these theories are related to statistics as well as condensed matter physics. So this way we will merge the subject, and we will do the numerical problem, that different type of numerical problem that often asked in the NetGate exam. Further, we are going to solve all the question paper that coming in the NetGate exam. Okay, and this is the list. Okay, quantum mechanics, best book is the Norwegian Jatili. You can find out any book online, Norwegian Jatili, and PDF copy is also available, and they will give you. Most of the question is come from here. Most of the question. And one more important thing I want to like to share, that in 2011 or 2012, UGC published a small booklet, and they have suggested this book for this exam, any exam related to physics. And they have clearly mentioned that for some book they have clearly mentioned that no question will be asked except from this book. They have clearly mentioned. I have followed this book. I have qualified. Many students already studied this book and qualify easily. Okay, don't study too many books. Study the specific book that is very essential. Okay, and this the quantum mechanics and Norwegian Jatili, it is enough for you. If you want, you can see this book, David Griffiths book, but this book is more efficient. And statistics, thermodynamics, for statistical part, you have to study R.K. Patharia book. It is essential. And for thermodynamical part, you have to study Faddered. And electromagnetic, David Griffiths is the best book. If you want, you can see the Matthew and Sadiku. Similarly, condensed matter physics, Kittel and Decker. This is a two book. One is written by Kittel, one is written by Decker. So most of the question related to Kittel, and 30% question comes from the Decker. So particle physics, David Griffiths, and for nuclear physics, Roy and Nikom, essential. If you want, you can study one book, and A. Dawson Farwell, particle physics, you can study. And nuclear part, many nuclear physical nuclear part is also included in that book. Atomic physics, for atomic part, Rajkumar you can study, because Rajkumar book is a simplified version of white book. But in white book everything is expressed in CGS unit, that's why I am not giving here. Okay, for spectroscopy part you have to study C and Benville. Classical physics, Goldstein is the best book, and Upadhyay, I forgot the name, surname I forgot. Upadhyay book, you can search in the Google, you can find it easily, it is a common book. So numerical problem you can see from this, but most of the question comes from the Goldstein only. So I will solve each and every problem related to this book. Okay, I will give you tips how to understand, how to study physics, how to solve numerical problem, how to understand the question in efficient manner. And mathematical physics, so Swarm series for complex variable and probability. This part, probability and complex variable, you have to study Swarm series. It's the best book, but it is not necessary to study whole topic given in the book. You have to study according to the syllabus. AWGC for matrix and tensor. And Afkin and Weber, it includes all the topic related to mathematical physics. Electronics, op-amp. Operational amplifier, this is very common part in exam, and you have to survey Ramakan Gaikwad. Robert Bollestad, device and electronic circuit. Okay, and Melvin and List, digital electronics. Digital electronics is another book, I forgot the name. So Donald Newman, Introduction to Semiconductor Physics. These are the book you have to study, but it is not necessary to study each and every chapter as well as each topic as mentioned in the book. Only you have to study specific portion that as per the syllabus. Okay, I will teach you all part topic wise, and most important part from where normally question are given, I will discuss in elaborate. I will solve numerical problem. I will give all it. So first of all, I will for today, actually first class, today I will focus on electromagnetic theory. So in order to understand, important thing is that in order to understand electromagnetic theory or physics as well as physics, you have to understand the vector calculus and coordinate system. Use of vector in electrodynamics is very, very essential. If you don't understand the vector, then you never understand the physics. So normally this coordinate system not often teach in classes because of lot of factor. With a time limitation and time limitation, as well as most of the part already included in BSc level. So even though I am teaching you coordinate system, there is a three coordinate system. One is cylindrical coordinate system, one is spherical coordinate system, one is rectangular coordinate. Rectangular coordinate system often familiar to everybody. We know everybody. But normally questions are based on cylindrical and spherical. But we have to know each and every detail of spherical and cylindrical so that we can understand the question in efficient manner. Okay, today I will first start coordinate system. So you carefully focus on the coordinate system. So spherical coordinate. Spherical coordinate is represented by T coordinate r, theta, phi. Rectangular coordinate x, y, z, and cylindrical coordinate r, phi, z. These are the coordinates you have to understand. So I am not going to give the detailed derivation of all coordinate transformation. I will give important relation and how to remember it. Okay, and those relations I am mentioning here, I am going to mention here, which are often used on all numerical problems. Okay, important part. So unit vector associated with simply r, ar, A is a unit vector, okay, and it is, you can represent r cap, theta cap, phi cap, but I am not going to like that. AR unit vector, unit vector, unit vector is, these are the AR, A theta, A phi, okay, or you can represent as r cap, theta cap, phi cap, you can represent like this. Here unit vector, you know, AX, AY, AZ, or you can represent X, I cap, J cap, K cap. So here you can unit vector AR, A phi, AZ, okay. You can also represent as R cap, phi cap, Z cap, Z cap or K. Okay, this is a typical way we normally represent in a book, but I am not going to this way, because if you forget to write the cap, then it will represent, sometimes it will, you will confuse with complex number. Normally complex number is also represented by I. So similarly, if you r cap is a unit vector along radial direction, but normally we write r cap, but if you forget to write cap, then it will become different. So in order to confuse that things, I simply write AR, A theta, A phi. These are the unit vector of spherical coordinate. These are the unit vector of rectangular coordinate system, and AR, A phi, AZ is the unit vector along cylindrical coordinate. So I will not use that part. I will simply write this. It is the better way to represent all the time without any confusion. So the small elemental distance, small elemental distance. Before that, I will test this unit direction. AR, A theta, A phi. This is what we always know. AX, X means IZK, AY, AZ. Okay. And this is what AR, A phi, AZ. So this thing is, we know unit vector, how it is related. Now you see, first of all, first important thing, AR is perpendicular to A theta, perpendicular to A phi. Always remember, unit vector in spherical coordinate system, AR, A theta, A phi, all are mutually perpendicular to each other, like Cartesian rectangular axis. Cartesian coordinate. Rectangular means Cartesian coordinate unit vector. Here we represent AX perpendicular AY, perpendicular AZ. Okay. Similarly, here AR perpendicular A phi, perpendicular AZ. Same property, it will follow same property like rectangular coordinate system or Cartesian coordinate system. Okay. This is the basic thing. Number one important characteristic. Number two important characteristic is that if we take the product AR into A theta, AR into A theta, it will be A phi. Okay. And similarly, in opposite, similarly, A theta into A phi equal to AR. Or reverse direction, it will anti-clockwise direction, it will be negative. Suppose A phi into A theta equal to minus of AR. Okay. Similar here also, AX into AY equal to AZ, and AY into AZ equal to AX. Or reverse direction, AZ anti-clockwise, AY equal to minus of AX. Similarly here also, AR into A phi equal to AZ, and A phi into AZ equal to AR, or AZ into A phi equal to minus of AR. So it will all follow like rectangular axis. Okay. Number four, magnitude of unit vector A phi A equal to AR equal to AZ. AR theta. Similarly, AX equal to 1. AY equal to AZ equal to 1. Magnitude unit vector. Because unit vector, that is why magnitude is 1. Okay. And similarly here also, AZ equal to A phi equal to AR equal to 1. These are the basic property, T coordinate system. Okay. Okay, I'm erasing this part. Next, all unit vector follow the similar rule as followed by in rectangular coordinate system. Okay. Next, elemental distance, small distance. So it will be better if you understand the rectangular coordinate system. Suppose if you take a cube, small cube. Suppose this is the distance dx. This is x-axis. This is y-axis. This is z-axis. This is z. This is y. Then elemental distance, small distance dr unit vector is equal to dxi, or you can dyj. J you can write ax. Okay, I will write ax, ay plus dz az. Okay, these are the unit vector. So these are the component. Okay, so this is the small elemental distance in rectangular coordinate system. So dx, dy, dz and unit vector ax, ay, az. So dv equal to how much? Dx, dy, dz. Volume is a scalar quantity, is a product of all three dimensions. Okay. Surface area. Now, whenever we consider the surface area, then what are the surface area? First, this one surface area. One is this one surface area. One is this plane. One is this plane. Three surface area along three direction, and three surface area in opposite direction. So, along dx, what happened? Whenever we consider surface area is a vector, we consider the surface area along x direction. X direction means this surface. We are talking about this surface. Then there will not be dx. How to remember? Whenever consider the surface area along x axis, means surface area vector is along x direction. So there will not be x. dy, dz and ax. Okay. Similarly, dsy. Whenever consider y, then there will not be dy. dx, dz, ay. Ay is a unit vector. And dz equal to whenever consider dz, so there will not be dz, dx, dy, az. Okay, three surface area of a cube and three surface area in opposite direction. So one dsx, dsy, dsz. So whenever consider x, there will not be dx. So rest of the two. Whenever consider surface area along this direction, product of this and this. Okay, and along x direction, unit vector will be along x. When you talk about surface area of this plane, y plane means this plane, then this part product of these two parts and y unit vector. Whenever to consider surface area along z, then this part and this part, dx into dy and unit along z direction. So this is how you can remember. Similarly, this is an elemental small distance in the rectangular coordinate system. In spherical coordinate system, this small distance is represented by. So how can you remember? Unit vector will be there first. First unit vector ar plus a theta plus a phi. It will be there. Plus a phi. Okay. First one will be dr. Second one will be r d theta. Whenever consider theta unit vector, there must be d theta. We are considering r, so there must be dr. Whenever I consider d phi, there must be d phi and r sin theta. Only you have to remember r sin theta and r. Whenever, again I am telling, whenever I consider AR, there must be DR. Okay, whenever I consider A theta, there must be D theta. Okay, whenever I consider A phi, there must be D phi. So, for only term you have to r sin theta is there and r. This is the elemental distance in spherical coordinate system. Okay, now what is the volume? Volume equal to how much? So, volume equal to product of this. So dr into r d theta into r sin theta, so d phi. This is the formula. So equal to r square dr r square sin theta d phi dr. This is the volume of a sphere. So when I ask you what is the volume of a sphere, when I ask you what is the volume of a sphere, you can easily say that volume of a sphere equal to 4 by 3 pi r cube. Okay, you always try to understand the volume of a sphere formula is r square sin theta d phi dr. Always remember. And 4 by 3 pi r cube is derived from this equation. So better, this is 4 by 3 pi r cube is a volume of a sphere in ideal condition. But if suppose this is a sphere. This is a sphere. If I cut a small portion like that, how can you evaluate the volume of this sphere? Small portion of a sphere is removed. Then you cannot say that 4 by 3 pi r cube. So you better to understand the volume, general formula of volume. This general formula is very easy. Only to remember this, the elemental length. Okay. So what will be the surface area? So now I am again telling, number of degree of freedom is how much here? Number of degree of freedom means number of minimum coordinate to specify the position of a single particle or one particle. So here degree of freedom is 3. So whenever there is degree of freedom is 3 degree of freedom, you will get 3 surface area. Okay, one along r direction. That surface area formula we often use in Gauss law application. Okay, so what is the formula? Along r direction. So whenever consider r direction unit vector, whenever we consider direction unit vector along r direction, then there will not be dr. Okay, you forget this term. Okay, product of this term and this. So product of first term is r d theta into r sin theta d phi, and unit vector will be along AR. So formula is r square sin theta d phi AR, unit vector. Okay, I will at the last I will discuss this part. So otherwise you will confuse. So surface area along, again I am telling, surface area along r direction. Okay, whenever we are considered to find out the surface area along radial direction, there will not be dr in the equation. Okay, so you just product of coefficient this term and this term. So r d theta into r sin theta d phi and unit vector along this AR. Okay, first one, 3 surface area will be, and ds phi along phi direction. Phi is the azimuthal angle. Is always in use in quantum mechanics for space quantization. Okay, but this surface area along phi direction will be. But whenever consider phi direction, you forget about this term. So it will be dr into r d theta, and unit vector will be a phi. Okay, easy, very easy. And third, ds theta direction surface area. Whenever consider theta, forget about this term. You have to write this first and third term. First term is dr, and last term is r sin theta d phi, and unit vector will be a theta. This is the 3 surface area of the spherical coordinate system. So no need to remember the formula. You just remember only the elemental distance, r sin theta d phi a phi. Okay. Now we often use the volume of a sphere. Volume of a sphere is 4 by 3 pi r. This is the formula we often use in application of Gauss law. And the surface area we often use 4 by 3 pi 4 pi r square. But from where we get this formula? Instead of remembering that things, you just try to remember the general formula. Okay, what is the general formula? dV, I told you, okay, product of three coefficient. So volume is a scalar quantity. No need to write unit vector. You just take the product of all coefficient, three coefficient. So T becomes dr into r d theta into r sin theta d phi. So it will be r square sin theta d theta d phi. Okay. Now this is the volume formula. Volume formula. So limit. Now you have to find out the volume of a sphere. So what is the limit? R limit 0 to infinity. Infinity means a radius of a sphere, maybe anything, we don't know, maybe infinity. 0 to infinity. So theta limit of theta must be this one, 0 to pi. Or if you want, you can sense minus pi by 2 to pi by 2. But total length is pi, remain constant. You can sense minus pi by 2 to pi by 2, result will not be affected by this change. Or you can sense 0 to pi. Phi limit, phi is the azimuthal angle, 0 to twice pi. This is the limit. Or you can change minus pi to pi. Upper limit, lower limit. But total length is twice pi. Okay. So now how can you get? See, volume of a sphere dV is equal to r square sin theta d theta d phi dr. This is the formula. So total volume equal to integral. Whenever we take the volume integral, it will contain three integral. One is along with respect to r, one is with respect to theta, one is with respect to phi. So it will be r square sin theta d phi dr. Okay. So I will expand in three part. 0 to r square dr. Okay. 0 to pi. Theta limit 0 to pi. Sin theta d theta, and 0 to twice pi d phi. So it will give, first term will give how much? R cube by 3. Okay. Second, this part, if we take the integration, it will be minus of cos theta. If we put this value, it will give 2. And this will give you twice pi. What we are getting? 4 by 3 pi r cube. This is the volume of a sphere. So volume of a sphere 4 by 3 pi r cube is a special case, but you always try to remember general equation. Why I am giving you that. So this is the volume. So and why it is very important? You focus on a question. So I will give a question. So determine the. Before that, I will go to the surface area. This is the limit. Surface area vector. Surface area. Normally, we often use this surface area along radial direction. So wherever we use the Gauss law, we write like this, na? Electric field direction. This is suppose circle in Gauss application. I want to recap some important thing from Gauss law. Okay, most of you already study in SS level, so I want to draw again, and I want to give you important hints. You always write surface area is a vector ds. Do you like this then? So this is what, or sometime in some book you will find like this. You will find like this. Suppose this is 0 q surge, this is r direction, this is electric field direction, and ds direction. So you sometimes you will find this type of diagram, and sometimes you find this diagram. Okay. So this surface area means surface area along radial direction. So elemental length I am writing you again dr or dl, whatever you can write dl also. Dr ar r d theta a theta r sin theta d phi a phi. This is the elemental length, small length in spherical coordinate system. When we talk about dr, so product of coefficient this part and this part, no need to take this up. R d theta into r sin theta d phi. Okay, and area is a vector, so it will be ar. Only this component you have to write. So it will form general formula will be r square sin theta d theta d phi. This is the general formula. So how can you get surface area of a sphere? We get normally we write 4 pi r square. This is the surface area. From where we get this formula? So you can find surface area is a integral 0 to r square. I will put directly 0 to r dr, integration of this part 0 to pi sin theta d theta 0 to twice pi, or there is no dr. Okay, this integral will not be there. R square is constant d phi. So r square it will give 2, and it will give 2 pi. So it will be 4 pi r square. Okay, is it? So instead of remembering this thing, you focus on general formula. General formula no need to remember. You just remember this general equation. So you can find out surface area along theta direction. Sometimes in net gate question, they are not going to ask you the total flux along radial direction. They will ask the total flux along the along theta direction. Find the total flux along the theta direction. Okay, this is how you have to remember. So what type of question often asked in an exam? So I will focus on that. I will not see. Determine the surface area. Question number. This question comes in the JST exam. Okay, JST exam. Determine the surface area of a cell r equal to 2, radius 2. Okay, and theta is equal to pi by 4 greater than theta less than equal pi by 3. Okay, this question comes in the JST exam. Determine the surface area of a cell radius r2. Okay, and theta is given this one. So what is the formula? That's what I am writing here. ds, r is constant. Okay, so surface area formula r square sin theta d theta d phi. This is the formula ar. Okay, so total surface area equal to r square constant. It will come out 0 to, you cannot write 0 to twice pi. Oh sorry, 0 to pi you cannot use it now because they have already given the upper limit, lower limit. So in that case you have to put the lower limit, it will be this one, upper limit will be pi by 3 sin theta d theta, and phi upper limit, lower limit not given in the question. You just put this 0 to twice pi d phi. Okay, it will give it a twice pi r square into this part. This is how you have to evaluate. Okay, this is in spherical system. So I am reminding you, always try to remember the small elemental distance. From that distance you can try to evaluate everything. Similarly, in last one is cylindrical coordinate system. Cylindrical coordinate system. Cylindrical coordinate system is the last one. R phi z. Small elemental length dl, or you can write dr also, no problem. First unit vector will be there, ar. Okay, a phi. Okay, az. You first write. Whenever a r unit vector, dr must be there. Dr. Here r d phi, dr. Here r dr. and here is R d phi, okay, and this is dz. This is the elemental length. Now, what is the volume? Volume dV, small volume. Volume is a scalar quantity, so there will not be unit vector. So volume will be product of these three coefficients, dr into R d phi into dz. Okay, so formula will be R dr d phi dz. So this is the volume. So suppose this is a cylinder. This is a cylinder. This is cylinder of radius r. This is r, length l. So what is the formula of volume of a cylinder? We remember volume of a cylinder is what? Pi r square l. Pi r square l. We know this volume of a cylinder, area into length. So from where we get this formula? So you try to understand the basic formula. What happen then? You can evaluate everything. Okay. So this is the volume. I will derive dr, this equation dr d phi dz. Okay. This is the volume. So what is that? So volume V equal to 0 to r dr. Okay. 0 to 2 pi d phi. Dz is the length, 0 to L dz. Okay, it will give what? 2 by r square into twice pi into L. Okay, 2 cancel. It will give a 4 pi r square L. Is it okay? So this is the general formula. You try to remember the general formula. Only thing is that you have to remember this. Okay, this is the volume. Why it is so important, I will teach you later. Why it is so important? Because whenever you apply in a Gauss theory or any electrodynamical problem, you have to apply this surface area, this volume according to the question. Okay. Suppose, okay, similarly surface area dl, I am writing it again, dr ar, r d phi is phi, dz az. Then what three surface will be there? One along x direction. When we talk about the surface area along radial direction, this coefficient non-necessary product of this r d phi dz. Okay, into ar unit vector. Similarly, the ds phi, then this coefficient non-necessary product of this coefficient, these two coefficients, dr dz a phi. Okay, and d Sz surface area along this direction. Along this direction means this surface area, this portion. Okay, this portion will be dz. Only these two coefficients is r, dr, d phi. This is okay. This is three surface area along three coordinate system. This representation of coordinate is very essential. So I am asking you to remember the elemental length. Elemental length in rectangular coordinates, everybody knowing dx plus dx I plus dy j plus dz k. But in spherical and cylindrical system also easy. How to remember? I am giving you tricks. If you understand, if you remember, you can find out anything. Okay. So why it is so important? The question the question number 2, that is asked in a net exam. If electric field is something like that k r cube r cube in spherical coordinate system, find the total size. How can you evaluate? How can you find out the surface? So we have to use this electric field Q rho by epsilon naught. This is the Gauss law or Maxwell equation. You have to find the rho from epsilon naught into divergence E Okay. Finally, what is the total charge? Total charge equal to rho dV. dV, whenever you have to volume, you cannot write 4 by 3 pi r cube. You have to write rho into what? R square sin theta dr d theta d phi. This formula you have to use every time. Every time you have to use, but because according to the question, limit of theta may change. Limit of theta as well as limit of r as well as limit of phi may change according to the formula. The limit will given in a question. You just put the formula and try to put the value. Okay. So today I will stop this part in coordinate system. In the next class we will start the quantum mechanics, and next class of EMT we will start the divergent curl gradient, how they are important, and divergent curl gradient representation of T vector parameter in rectangular coordinate system. We everybody know it, but how can you represent this T parameter vector parameter in spherical and cylindrical system? But most net gate question comes comes from spherical and cylindrical coordinate. That is why understanding of this way in efficient way is very essential. So I will give a short tips how to remember and how to apply the numerical problem. And third important point, how to determine whether this is spherical or whether this is a cylindrical problem. So I will tell you in detail in the next class. Okay, thank you.